Okay, we're going to do final review number 2, and that's going to be finding the solution to a system of linear equations. You're going to be given 2 equations, and we're going to use the graphing and substitution method in this particular recording. When you're graphing, you look at each individual equation separately, and you graph it using slope-intercept form, because this is written in the form y equals mx plus b. The m for y equals negative 3x minus 8 is negative 3, the slope. And the b or y-intercept for the equation is negative 8. So we're going to plot negative 8. It's going to slope negatively. Now I can't go down 3 and over 1 and be on the graph, so I'm going to have to go up 3 and 1 to the left. I'm going to go up 3 again and 1 to the left. And I'm going to go up 3 again and 1 to the left. Because I don't have a ruler, I have to put a few more points in so that I can actually connect those points in some fashion that looks pretty good. So now I'm going to switch colors. You don't have to do that. And then I'm going to graph y equals 1/3 x plus 2. I've purposely put a fraction in because some of you struggle a little bit with this. The y-intercept, the b is 2, so I'm going to plot it. The slope is positive, and I could go up and to the right, but I need to get to a point of intersection with the red line, so I'm going to go down. I'm going to use the slope now, go down 1, the rise is 1, and I'm going to go 3 to the left. 1, 2, 3, and right away I'm hitting this negative 3, 1. That's going to be my point of intersection. But in order to draw my line, I'm going to have to do a rise of 1 and back 1, 2, 3, plot a point. Might even go up 1 and 1, 2, 3, plot a point. Now I have the ability to draw a somewhat decent line. You're going to use a straight edge, but I don't have one. So the point of intersection of the 2 graphs is going to be negative 3, 1. Ordered pair. Make sure you put it in parentheses and put a comma in between. Now for substitution, we are also going to come up with negative 3, 1, but we're going to do it differently. They're the same exact equation. When you substitute, you take, both of these are y equals. So you're saying that both of these equal y, so if I take this 1/3 x plus 2 and substitute it into the y spot, then they will be able to figure out what my y equals. So it's going to be 1/3 x plus 2 equals negative 3x minus 8. I'm going to collect the variables, so I'm going to add 3x to both sides. We try to keep our variable coefficient positive, so it'll be 3 and 1/3 x plus 2 equals negative 8. I'm going to subtract 2 from both sides using the subtraction property of equality, and I end up with 3 and 1/3 x equaling negative 10. Now again, you've ended up with a fractional amount. For some of you, that's a troubling moment. Okay, in one hole, there's 3/3. In 2 holes, there's 6/3. And in 3 holes, there's 9/3. You can also get that by going 3 times 3, which is 9. So you have 9/3 plus 1 more third, which is 10/3. Some people do it by going 3 times 3 is 9, plus 1 more is 10, 10/3. So we have 10/3 x equaling negative 10. Now to get x isolated, I'm going to need to multiply by the reciprocal of 10/3, which is going to be 3/10. 3/10 times 10/3, the multiplicative inverse, or the reciprocal, give you 1x or 1, or 1x or x. Then you have to multiply the amount on the right by 3/10. May help you to put a 1 under the negative 10. So negative 10 times 3 is negative 30. 1 times 10 is 10. And then negative 30 divided by 10 is negative 3. So there's your x amount. It matches. So in the solution, it's going to be negative 3 for the x. I'm now going to find my y. You can circle this, but that's not your final answer. Your solution has to be an ordered pair. I'm going to choose to put it into the first equation. So y equals negative 3 times negative 3 for the x value minus 8. And y equals negative 3 and negative 3 is 9 minus 8. And so y equals 1. So my y coordinate is 1. And my ordered pair is negative 3, 1, just like it was for the graphing. Now on the next problem, on this next problem, I need you to find your I need to use the graphing method to find your solution and then the substitution method. Write your m and your b, which we have here. M is 2, b is 2. And for the second equation, m is -1, b is -4. And then you're going to graph that, find your solution, and then when you substitute, the negative x minus 4 goes into this y position here. Then you will solve and find your x, and then after that you have to find your y, and these two solutions will be the same. So I gave you a little extra clues here we won't on the last one. As soon as you're done recording this, or as soon as you're done solving this, I want you to turn the recording back on again and check your answer. So I'm giving you the setup. I want you to turn your recording back on and check your answer, please. Okay, so I gave you a lot of clues on this one just to remind you how to do it. We graphed the first equation, b is 2. We plotted that ordered pair. It's got positive slope. I initially went up 2 over 1, down 2, back 1, and made one more down 2, back 1, because again, I need a lot of points when I don't have a straight edge. For the equation y equals negative x minus 4, I plotted a y-intercept, a b, at -4. The slope is -1, so it has to fall from left to right. So I went up 1 and 1 to the left, and down 1 and 1 to the right. But I knew that I needed to intersect with the red line, so I continued to go up 1 and 1 to the left, and I intersected at the point -2, -2. Then I did the same equation, only using substitution. So I substituted negative x minus 4 into the y position, because y equals negative x minus 4. So negative x minus 4 equals 2x plus 2. Collect the variables on one side. Try to keep the coefficient with the x positive. So it was 3x plus 2 and then -4. Subtract 2 from both sides using the subtraction property of equality. 3x equals -6. Divide both sides by 3 using the division property of equality, and x equals -2. There it is right there. You can circle it, but you need to put it into the ordered pair. I chose to use the y equals 2x plus 2 to substitute back into, so y equals 2 times, substitute in the -2 for x, plus 2. Y equals 2 times -2 is -4 plus 2. -4 plus 2 is -2, so y equals -2. The answers, as you can see, match exactly. Okay, you have one more of these to try, and let's go to that next. You'll write down the problem, you'll solve it, and then you'll pause your recording to be able to to be able to do the work, and then you'll check it. Okay, your paper's still divided. Graphing on the one side, substitution on the other, you'll get the same answer. What you're going to see is that the point of intersection in the graphing is the solution, so you actually get to visually see that the point of intersection is the solution. Y equals 1/2 x plus 1, write your m and your b, then graph it for the graphing. Y equals -3x minus 6, write your m and your b for the graphing. Find the point of intersection, make sure you use a straight edge to draw your lines. For substitution, you will substitute the -3x minus 6 right here into the y position in your first equation, because y equals -3x minus 6. You're just substituting in the y value of -3x minus 6. When you are finished, turn your recording back on, please, and check your answer. Okay, for y equals 1/2 x plus 1, the m is 1/2, the b is 1. You plot 1, you go up 1 over 2, 1 over 2. I went back 1 and back 2. Drew my line. For y equals -3x minus 6, m is -3, b is -6. Started at -6 for my y-intercept. Go up 3 over 1 to the right, up 3 over 1 to the, over 1 to the left, up 3 over 1 to the left. And I'm going that way instead of going down and to the right because I'm trying to intersect with that red line. It eventually intersects at -2, 0. You'll get the same answer for substitution, it's just a different method. Okay, now we're using substitution. Y equals -3x minus 6, so we substitute that -3x minus 6 for y. So -3x minus 6 equals 1/2 x plus 1. We want to keep the coefficient positive, so we add 3x to both sides to collect the variables on one side. So -6 equals 3.5 x plus 1. We subtract 1 from both sides. We're beginning to isolate the variable now using the properties of equality. So negative 7 equals 3 1/2 x. Now you cannot do anything with it as 3 1/2 x, but for every whole there is 2 halves. So in one whole there would be 2 halves, and 2 wholes there would be 4 halves, and 3 wholes there would be 6 halves, plus 1 more half would be 7 halves. So you are going to have there was a little negative there. It was actually part of the equal sign. I got rid of it. Okay, so you have 3 halves x, which is going to be, excuse me, 6 halves plus another half is 7 halves. So we have 7 halves x equaling negative 7. You multiply both sides by the reciprocal of 7 halves, which is 2 sevenths. 2 sevenths and 7 halves is 1, x or just x. And then I have 2 sevenths times negative 7. It's usually easier to put a 1 underneath there. Numerator times numerator, and 2 times negative 7 is negative 14. Denominator times denominator is 7 times 1, which is 7. That's negative 14 divided by 7, which is negative 2. So x equals negative 2. That matches with the previous x coordinate. Now we need to find y. I'm going to go ahead and choose the first equation because everything's positive. Y equals 1/2. We substitute for x the negative 2 plus 1. Half of negative 2, taking half of something is like dividing by 2. So negative 2 divided by 2 is negative 1. Y equals negative 1 plus 1. So y equals 0. So negative 2, 0 is the exact same answer that you get for both of these, just a different method of going about doing that. Now make sure that you have your 2 problems done and your graph done. If you did the actual problem, the first one, together with me, then submit that as well, but you need to have at a minimum done the 2 problems with graphing and substitution with the 2 graphs attached. And then you're going to turn that in to me. Watch any part of the video or all of the video if you're struggling with how to do this.